Thanks for joining me today. My name is Sahdev Zala. I work at IBM, and we'll be talking about PyTorch. Just a little bit about me in context of this talk. I am an open source developer for a long time now. From starting this year, I'm contributing to the PyTorch project as a developer, and I also lead a team of developers at IBM who contributes to the PyTorch. I'm also a technical lead in Kubernetes, where I serve as a maintainer for etcd project. And previously, I was a technical lead in the OpenStack and Oasis Tosca project. With that, so what I will cover today is basics of deep learning, PyTorch. Then I will pretty much give you the end-to-end flow of how PyTorch can help you to build models, to train them, and to validate. And then a couple advanced topics in the distributed training areas. And then I love open source. That's what I do at IBM. So I'm going to talk about how you can contribute to the PyTorch as well, if you're interested. We may not have much time for questions, because of the talk time. But feel free to connect with me. I would love to get connected. And I'll be also doing volunteering work at the PyTorch Foundation booth, which is right across the door, number 61. So come see me today and tomorrow as well. All right, so before I jump to the next slide, just a couple quick questions. Easy questions. How many people already are familiar with deep learning? And how about PyTorch? Few on PyTorch as well. Now, the difficult questions. How many of you heard about ChatGPT? Oh, pretty much everybody, okay. How about Tesla's autopilot mode? Okay, everybody, cool. So, you are already using offerings based on deep learning, okay? I'm just going to go over a few common terminologies in deep learning. This applies to PyTorch and in general to any deep learning platform. So deep learning is it's a branch of machine learning, and you're basically using a neural network with multiple layers. So with deep learning, you can think that there will be at least 2 or more hidden layers. There will be like input layer, output layer, and between that, there will be hidden layers. So deep learning usually have 2 at least. With today's large language models, foundation models, what we call, there will be many hidden layers. And you'll be learning from large amount of data, right? Your model. One of the things that has made AI mainstream, deep learning mainstream in past few years is the, as we know, availability of huge amount of data that we have today. And PyTorch is a framework for deep learning, and we'll talk more. But some of the use cases, as we just talked, right, like generating new content, generating code, summarizing text, speech to text, and image recognitions, and that kind of things. Second thing I want to mention quickly is tensor. Okay, there are some jargons in all technology fields, in AI, and everywhere. But tensors, you will hear or read that term frequently. So tensors are nothing but they are multi-dimensional arrays that are used for computing purpose, for numerical computations, right? There's a lot of math involved with deep learning. In PyTorch, tensors are the primary data structure. So everything from input layer to the output, in between the hidden layers, everything is numbers. Everything stored in the tensors. Okay. Model parameters, that's other thing we read a lot, right? With ChatGPT, IBM Watson X, or all the big platforms. Like, oh, there is a new model came out with few billions parameter. Oh, there's one came out with 100 billion parameter, right? And so on. So these parameters are basically variables that are optimized during the training process for your predicted output that you want. And there is a forward pass, as the term says, forward pass. You basically run the input through the model. in a forward way, and the backward pass is basically you traverse backward, and that's where the magic happens, right? That's where you optimize the parameters and find the gradient when using the gradient-based deep learning. All right, so as I said, PyTorch is a machine learning, in particular deep learning framework. And as you see in this diagram, there's input layer, there are multiple hidden layers, and this output layer, is just the standard deep learning. But what I mean by a deep learning framework is that PyTorch provides you all the building blocks to build your neural network, your model. And it also provides you the capabilities to train that model. Now, as you know, deep learning is very complex, okay? But, this is other thing that I would say, which, the things that has made AI mainstream lately is, technologies like PyTorch, which takes care of all these complexities, or most of the complexities of deep learning for you. And we will, in the next slide, we'll go through that flow. The reason we are here today in this talk is because PyTorch is an open source project. It's a project under PyTorch Foundation. It came out of Meta, but last year it became a fully open governance project under PyTorch Foundation. And PyTorch Foundation is basically part of Linux Foundation, so you can you can safely assume that there is a dynamic community behind the project. All right, so what more here? Tensor, I just mentioned in the previous slide, right? So this tensor in PyTorch, they can run on CPU as well as on GPU. Now, that's third thing I would mention, this computation power that we have today, that's other thing that has made AI mainstream, right? Because it's a hungry of computing power. But on top of that, accelerating this hardware, this computing power, that's a key. And that's one thing that, PyTorch, one of the things that PyTorch provides. You can run these tensors, and basically you can train your model on CPU, GPU, in parallel, multiple CPUs, GPUs on a machine. And you have to scale your training, right? So in a distributed environment with multiple GPUs on multiple machines. And PyTorch provides you, libraries for many domains, like, for computing vision, for Torch audio side. So there's a Torch audio library. From the text side, there's a Torch text. We all love doing things on your phone, right? So on your mobile devices. So there is a beta already out there. More efforts are going on to run PyTorch on your phone, right? On mobile devices. And the other thing is the community also provides you different tools like Torchbench that you can use to benchmark your models. All right. So you use PyTorch, as I said, for like end-to-end flow here, right? What do you need for your machine training? Well, data, of course. So let's say you have a data set which is curated by data scientists. For like large models, there will be data sets which are in terabytes and petabytes, right? How do you feed this data for your training? How efficiently you can do it? That's one of the things you definitely want. You can do it by yourself, but that will add complexities to your training process and extra code and whatnot. So PyTorch provides you two things: data sets and data loader classes. That data sets you use to download the data from your wherever the data is, and then PyTorch itself provides you many data sets, the built-in data sets that you can use for different domains, as I mentioned earlier. And then you use the data loader class to iterate over this data so that you can feed this data in something called like batch, right? With this humongous data sets, you probably will not train them like a one image, for example, in image classification, right, at a time, but you're gonna feed them in a batch, With data loader, you simply set that flag, and the data loader instance will do it for you. The second thing is, as it's common with us as a human, if you just do something in order, you just memorize things, right? So if you just provide data in order, the model will just memorize. It will not really train itself. So you want to do things like shuffling what using for training. That's another thing you can just use by just setting the flag. And there are other things that these two classes provides. Then you need a model, right? You got to build your model. Now it used to be very complex, as I mentioned, but with PyTorch you basically just I just provided a snippet there. But you basically just extend the nn.module, and you just then call the different layers. Again, it's a deep learning. There are multiple layers. PyTorch provides you many built-in layers. You just simply call them. So like here I'm using the linear layer, using the activation function, and then I have like 3 layers here. Just for the brevity, I just have this snippet here. But then you just instantiate the model, and that's it. That's the model that you're going to use for your forward pass, for your training, and later for inference, right? So when you talk about training, the complex part, as you see here in the snippet at the bottom, it's again simple training loop. This is again simple example, so you can have more complex things depending on your use cases. But you need things like a loss function. PyTorch provides you. There are multiple loss functions. You can use the one which fits your need. There are optimization functions that you will need to optimize your parameters, right? So once you choose what you want, you basically run this training loop where you, as using the snippet, you're just providing data in a batch, and you run your forward pass, okay? At the end of the forward pass, basically you get your output, and at, the first pass, those parameters that I mentioned, they are randomly provided by PyTorch. And at the end of the first pass, you will see, oh, I am, it's not going to be predicting right in the first attempt, right? So like, oh, I am this far from what I want, right? That's your loss function. That's your loss you will see. And then it's gradient-based training, so you go backward. As I mentioned, backward pass or backward propagations, whatever you call. But PyTorch has this feature called auto grade, and that's by far the most popular feature of PyTorch. It will calculate automatically the gradient for you. Okay, it can be very complex, as I said, but it will take care of the gradient calculation for you. You basically just call the backward function, and that's it. And then using that gradient, the optimizer function, you just step over, you tweak or optimize or update your parameters, and then you just go through that loop, right? So you have like, depending on your need, 3 epochs, 5 iterations, or 5 epochs, whatever you want. But at certain iterations, that, oh, my model seems now trained, right? Because you're exposing this huge data sets, the images in this case, multiple times. And at that point, you're like, hey, I want to validate what I have. And that's, again, you just write like a few lines of code. You call the model.eval function, which is basically will not do certain things that PyTorch do for you automatically when you train them. For example, batch normalizations or dropping out certain features for faster training. And as you see here in snippet, I'm using this no grade. So with no grade, you basically saying that I don't want a gradient. My testing is just forward pass, right? At the end, I want to know what's the accuracy of my model prediction. If I'm happy, I can use the model for whatever I want, or you do further training, right? The primary interface, as you can see here, it's a Python, which is, I'm sure by far the most popular language in AI community, with the data scientists. And if you don't know Python, it's easy to learn as well. C++ is also supported. The same thing I showed you here. You can use it and write in C++, and have your model ready. The couple of quick thing here I want to mention, like I said, these are the advanced topics. But distributed training is important because that's where you're gonna scale your training. So PyTorch provides something called distributed data parallel where you can replicate your model across GPUs. Now, as I said, these models in real life, especially these bigger ones, large language models, foundation models, they are big ones, right? You will fine-tune them according to your need, as we know, but initially, with bigger models, you basically replicate among different GPUs and train them. DDP is very widely used, but then we have challenges always, right? How about the memory footprint? It's huge because it will replicate across different GPUs. So that's what something called fully sharded data parallel. The work is already, it's in progress, but it's already out there. There was some release for FSDP as well. That basically shards the parameter of model. So basically, you're sharding the model across different GPUs. That reduces the memory footprint and gives you faster training. At IBM, we contribute to different parts of PyTorch. FSDP is one. I just provided a link on here that if you wanna take a picture or wanna search later. But we have done a really good job with 500 plus GPUs with 60 plus nodes, showing how to scale the training with FSDP. All right, moving to the next slide, contributing. I'm sure many of you would like to contribute, right? And contribute in different ways, with code or non-code ways, but you can do either way. The github.com/PyTorch has many repositories that you can contribute to. That is a core PyTorch repo and other domains, as I mentioned earlier, like Vision Library or Audio Library or Torch Bench. With any open source project you contribute, refer to the contributing.md file for what the project is asking you. Sign the contributor license agreement, follow code of conduct, and as I mentioned, you contribute to any areas, right? Through the code, documentation, looking at the open issues and triaging those issues. There are a few thousand issues are open right now in the PyTorch repo. Even reporting issues is a good contribution, right? If you're using PyTorch, you run across some bugs or something not working, just open an issue. Help towards community development. If you're an advanced developer, work on implementing some features, improve test coverage. Any way you can help, right? And as I mentioned, Python, C++ are kind of good skill there. And you follow the open source etiquettes. IBM DE here gonna have a good talk tomorrow at here, where I think you're gonna go deeper in that topic. So please attend that talk. All right. So as I mentioned, just so that one slide from my employer, right? Watson X. That's IBM's new AI platform, and as you see, it's built on top of tons of open source projects, and PyTorch is a core component that we use for training the models. So you can, I'll be very happy if you can just try the Watson X, just see how we use PyTorch, how we leverage. There are some other, learning resources. PyTorch.org has lots of good material to learn about PyTorch, many tutorials and whatnot, and the GitHub repo, as I mentioned. As well as there's a, if you are interested in how we do open source at IBM, there's a link there as well. Well, with that, as I said, we don't have much time. Please feel free to connect with me if you have any questions, through my Twitter or email, or I'll be right across the doors, and just stop by, we can have a chat. Well, thank you so much.